All right, let's go. Number 10, the Bonneville Flood. In the low hills of southeastern Idaho, there is a shallow saddle in the land called Red Rock Pass. Cars drift through it on a two-lane road. Cattle graze the slopes. Nothing about the place suggests violence. But this quiet gap is where one of the largest inland floods in North American history began, roughly 18,000 years ago. A lake the size of a small sea had found a way out. The lake was Lake Bonneville. During the last ice age, it filled much of what is now the Utah desert, a body of fresh water holding as much as Lake Michigan holds today. The old surface is still legible on the mountainsides above Salt Lake City. High on the slopes of the Wasatch Range, faint horizontal terraces run for miles. The stranded beaches of a vanished shoreline, some of them nearly 1,000 feet above the valley floor. The lake was real, and it was enormous. For most of its life, Bonneville had no outlet to the sea. Then its rising level reached the low divide at Red Rock Pass, held back only by a natural dam of loose gravel and alluvium. The water began to spill, and once it started to cut into that soft barrier, the process fed on itself. But here's where a slow overflow became a catastrophe. The trickle widened the notch. The wider notch carried more water. The heavier flow cut faster. Within days, the barrier at Red Rock Pass unzipped, and the top of an entire inland sea poured north into the valley of the Snake River. The peak discharge has been estimated at roughly 1 million cubic meters per second. That is about 500 times the largest flow ever measured on the Snake River at Idaho Falls. It is on the order of 4,000 times the normal flow of the Colorado through the Grand Canyon. The evidence sits in the canyons downstream. Geologist Grove Carl Gilbert described the old lake shorelines in the 1870s, but the flood itself was largely forgotten for decades. In the late 1950s, the geologist Harold Malde traced scoured bedrock and strange boulder deposits down the Snake River plain and connected them to the Bonneville overflow. He and a colleague gave the boulders a name after seeing a roadside sign that called them petrified watermelons. Melon gravel, rounded basalt boulders 3 to 5 feet across, some larger, stacked in bars where the flood dropped them. Near Red Rock Pass, house-sized blocks of limestone were shoved out of place and left where the water abandoned them. The flood drained the top 100 meters of Lake Bonneville on the order of 5,000 cubic kilometers of water in a matter of weeks. It deepened the Snake River Canyon. It carved the cliffs at Shoshone Falls and Twin Falls. The whole shape of southern Idaho's river country is, in part, the record of a single lake emptying itself. What remained afterward is a shadow. Lake Bonneville shrank as the climate dried. All that was left was the Great Salt Lake, 40 feet deep and too salty for fish, a fraction of the freshwater sea that once mirrored the sky over Utah. The beaches still line the mountains. The melon boulders still sit in the canyons, too heavy to have been moved by any river that flows there now. They are the only witnesses left to a wall of water that no one saw. Number 9. The Altai megafloods. In the valleys of the Altai Mountains of southern Siberia, there are long ridges of gravel that look, at first, like ordinary low hills. They rise in regular rows across the floor of the Kurai and Chuja basins, spaced out at intervals, their crests smooth and rounded. For a long time, no one understood what they were. Then, in the 1980s, the Russian geologist Alexei Rudoy looked at them and recognized something almost impossible. They were ripples, not hills shaped like ripples. Ripples, in the exact physical sense of the word, the same feature that water leaves in the sand of a stream bed when a current flows across it. Here the ripples stood up to 16 meters tall and were spaced roughly 200 meters apart. To sculpt ripples that large, the current cannot be a stream. It has to be a flood hundreds of meters deep, moving with enormous force. For most of the 20th century, geologists had simply misread them. Nobody yet had a category for a landform built by a flood on this scale, so the ridges were mapped as ordinary hills or glacial rubble, and their real meaning went unseen. Rudoy worked out the source, and later expeditions with the American geologist Victor Baker confirmed the picture by comparing the Altai landforms to the famous scoured terrain of the Pacific Northwest. During the Ice Age, valley glaciers pushed across the Chuja River and dammed it with walls of ice. Behind the dam, a lake filled the Kure and Chuja basins. It reached an elevation of about 2,100 meters and held roughly 600 cubic kilometers of water, some 500 meters deep in places. It was a hidden sea. Its old shorelines are still etched at different heights around the basin walls, faint terraces marking where the surface once stood. It was a lake trapped in the mountains, held back by nothing but frozen water. And ice dams fail. When this one broke, the lake emptied down the valleys in a matter of days, sometimes less. Estimates of the peak discharge have ranged as high as 18 million cubic meters per second in the early studies. More recent models settle closer to 10 million. Either figure ranks among the largest freshwater flows the planet has left any trace of. The water tore through the gorges at speeds approaching 60 meters per second. Along the way, it dropped mounds of debris the researchers call giant bars. Some are 5 kilometers long and more than 100 meters high. Sediment stacked by a current no river could produce. Then the glacier advanced again. The dam reformed, the lake refilled, and the whole cycle began once more. This was not one flood. It was a machine that flooded on a schedule, over and over, across thousands of years. The scale of it is extraordinary, and the strangeness is that almost none of it is visible as water. The lake is gone. The glaciers that dammed it have retreated. What is left is the pattern the water pressed into the ground on its way through. These are the largest current ripples known anywhere on Earth, standing in silent rows in a quiet Siberian valley. Walk among them today, and they pass for ordinary hills. Only from the air does the pattern resolve into what it truly is, a streambed made for a monster. They are the fingerprints of a sea that formed and drained and formed again, hundreds of meters deep, and left nothing behind but the shape of its own passing. Number 8. The flood that carved the English Channel. In 2007, Sanjeev Gupta and Jenny Collier, geologists at Imperial College London, published a map of the floor of the English Channel that solved a mystery almost 2 centuries old. The question was simple and strange. Britain is an island. It was not always one. For long stretches of the ice ages, when sea levels dropped, dry land connected England to France, and human beings and animals could walk across. So how did the connection break? And why did it break for good? The puzzle itself was old. As far back as 1823, England's first academic geologist, William Buckland, had suggested that the rivers of the southern North Sea once ran across land that is now the Strait. The naturalist Thomas Belt returned to the idea in a letter to the journal Nature in 1874, and it passed through the correspondence of Charles Darwin and Alfred Russel Wallace. But no one could offer a convincing mechanism for how a ridge of solid chalk had been cut through. For a century and a half, the question sat open. The answer Gupta and Collier found was written in the bedrock beneath the water. Their sonar map revealed a vast valley cut into the floor of the channel. Inside it lay the unmistakable signatures of catastrophic flooding, streamlined islands shaped like teardrops, long parallel grooves scoured into rock, deep basins gouged out and left behind. These are not the marks that rivers or tides leave. They are the marks that a colossal, fast-moving sheet of water leaves. Here is what the map recorded. Hundreds of thousands of years ago, a ridge of chalk ran from Dover across to Calais, a natural wall joining Britain to the continent. To the north lay an enormous lake, filling the basin of what is now the southern North Sea, fed by the Rhine and the Thames, and pinned in by ice sheets. That lake rose until it overtopped the chalk ridge. Then the ridge failed. The lake tore through the gap and flooded west down the channel. The discharge is estimated at around 1 million cubic meters per second, roughly 1,000 times the flow over Niagara, and it ran at full force for months. It reordered the rivers of an entire region, forcing the Thames and its neighbors to drain down the new channel rather than north into the sea. and later work confirmed it happened in stages. The strait opened in at least two great episodes, once around 450,000 years ago, and again long after. Each one deepened the breach, until Britain was severed for good. What makes this flood matter is what it did to people. Gupta and his colleagues argued that the breach helps explain a haunting gap in the record. Before the ridge broke, early humans reached Britain on foot. After it broke, and the sea claimed the strait, the archaeological signs of human presence in Britain vanish for something close to 120,000 years. The flood did not just cut a channel through chalk. It severed a peninsula from a continent and closed the door behind a whole population. Other flood specialists judged the case a strong one, with only the precise timing left to settle, and later surveys of the strait floor confirmed the two-stage opening in still finer detail. The strait is still there. 20 miles of gray water, one of the busiest shipping lanes in the world, ferries and tankers crossing it every hour. Almost none of the people who make that crossing know what lies beneath their hulls. A drowned canyon in the bedrock, carved not by the sea, but by a single lake bursting its wall. It is the flood that turned a corner of Europe into an island and kept it that way. Number 7. The Black Sea Deluge. Two marine geologists at Columbia University spent much of the 1990s reading the mud of the Black Sea floor. Their names were William Ryan and Walter Pittman, and what they believed they had found became one of the most famous and most fiercely contested flood claims in modern science. In their reconstruction, the Black Sea about 7,600 years ago was not a sea at all. It was a freshwater lake, its surface more than 100 meters below the level of the world ocean. A barrier of rock cut it off from the rising Mediterranean in the narrow valley of the Bosphorus, where Istanbul now stands. The two were separate. The lake had its own low shoreline, and along that shoreline, they proposed, people farmed. It was dry land. The evidence that drew them was buried in the sediment cores. On the drowned shelf, they found an abrupt change. Freshwater deposits giving way, almost overnight in geological terms, to the shells of salt-tolerant mollusks that live only in the sea. Something had turned a freshwater lake into an arm of the ocean, and it had done so quickly. The shells marked the moment. Ryan and Pittman argued that the Mediterranean, swollen by melting ice sheets, finally broke through the Bosphorus barrier. Once the breach opened, they calculated, seawater poured through it something like 50 cubic kilometers a day. The torrent ran at full spate for the better part of a year. It drowned more than 100,000 square kilometers of land and drove the shoreline inland by as much as a kilometer a day. Picture a wall of salt water crossing a farmed plain, faster than a family could pack, and move ahead of it. In time, a region larger than many modern countries lay beneath a new sea. And then they made the claim that made the story famous. The farmers who fled that rising water, they suggested, carried the memory of it into the ancient Near East. That memory became the seed of the flood legends that echo through Mesopotamian and biblical tradition. It is the story we now attach to the name Noah, a real catastrophe, remembered in story for thousands of years. The idea seized the public imagination. The undersea explorer Robert Ballard, who had found the wreck of the Titanic, mounted expeditions to the Black Sea floor. He reported traces of an old, drowned coastline far below the modern surface, and even the possible remains of a structure. It is a powerful idea. It is also disputed, and the dispute runs deep. Other geologists read the same region and reached the opposite conclusion. A group led by Ali Aksu and Richard Hiscott gathered seismic profiles, cores, and radiocarbon dates. They argued the water was flowing the other way. The Black Sea, they said, sat higher than the Mediterranean and drained outward through the Bosphorus, not the reverse. In a detailed review spanning decades of data, they found no clear signature of a sudden, violent inflow. Others, including a study led by Liviu Giosan, accept that the sea did rise. But they calculate it rose far more modestly, on the order of a few meters, reaching only a fraction of the flooded area Ryan and Pittman had proposed. The one thing everyone agrees on is that the shells changed, that a freshwater lake became a salty sea. The argument is over how fast, how deep, and in which direction the water moved. So the truth sits underwater and unsettled. The old freshwater shoreline still lies drowned, roughly 100 meters down, somewhere out on the Black Sea shelf. Whether it went under in a single roaring year or crept under across a slow century, the researchers have not agreed. And whether any human being stood on that shore, watched the water climb, and carried the story to their children is something the mud has not chosen to tell us. Number 6. Meltwater Pulse, 1A. The coral was the clue. In 1989, the geologist Richard Fairbanks drilled cores from the drowned reefs off the coast of Barbados and pulled up a record of sea level stretching back 17,000 years. Reef-building corals are exacting timekeepers. Certain species grow only in bright shallow water near the surface. Where their fossils turn up, they mark almost exactly where the sea once stood. And the cores held a shock. At one point in the record, the shallow reef crest simply drowned. One species in particular tells the story. A branching coral called Acropora palmata lives only in the top few meters of clear, sunlit water. That makes it a razor-sharp gauge of where the sea once stood. In the cores, the corals that had been growing near the surface were suddenly far too deep. The reef had to abandon its old position and start again higher upslope, chasing a surface that was climbing away from it. The only thing that explains it is a burst of sea level rise so fast that living coral, one of the quickest building structures in the natural world, could not keep up. Fairbanks named the event Meltwater Pulse, 1A. The same signal turned up in drowned reefs off New Guinea, and most precisely, off Tahiti. That island sits far from any former ice sheet and far from the crumpling of the seabed at plate boundaries, which makes its record unusually clean. The Tahiti corals pinned the pulse to a window around 14,600 years ago, at the onset of a sharp global warming. In that pulse, the ocean rose somewhere between roughly 14 and 22 meters in no more than a few centuries, perhaps as little as 340 years. That is a rate of 4 to 5 meters of sea level rise per century, something on the order of 10 times the pace of today. Where all that water came from is still argued. The candidates are the collapsing ice of North America, of Northern Europe, and of West Antarctica. Recent work suggests the melt cascaded from one source to the next. Nor was Meltwater Pulse, 1A, the only jump. The same drowned corals recorded a second surge a few thousand years later, and across the whole long thaw, the ocean climbed roughly 120 meters from its Ice Age low. Every coastline the Ice Age had drawn was rubbed out and drawn again, higher, further inland, until the map of the world's shores became the one we know. What makes this flood so unsettling is that it had no dam and no wave. There was no barrier to break, no single valley to drown. The ocean itself simply rose, everywhere on Earth at the same time, fast enough to leave a coral reef gasping beneath it. It was a flood you could not have run from, because there was nowhere it was not happening. There was no high ground to reach. On a flat coast, that kind of rise does not lap gently at the shore. It walks the sea inland across the land, mile after mile, within a single human lifetime. A hunting camp that stood well back from the water at a child's birth could be a beach by the time that child had grandchildren. Open sea, a lifetime after that. The drowning was slow enough that no one would call it a flood in the moment, and fast enough that no coastal people could hold their ground against it. And this is the flood that did the drowning in the stories still to come. The same rising ocean swallowed the plains of the North Sea and the vast lowland shelf of Southeast Asia, homelands that had been dry for tens of thousands of years. Exactly which melting ice sheets fed the pulse, and whether it disrupted the ocean's circulation, remains argued among specialists. But the pulse itself is written plainly in stone, in reefs that died where the water passed them. Could it happen again? The dam bursts and the tsunamis on this list belong to a vanished ice age. This one does not. Of every mechanism in this entire countdown, the rise of the sea over the shore is the single process that has never actually stopped. Number 5. The flood that turned the world cold. In 1999, a team led by Don Barber, then a young researcher at the University of Colorado, published a study in the journal Nature. It traced the coldest snap of the last 10,000 years back to a single flood. And this was a flood no human eye could have watched, because it emptied not onto land, but into the sea. The reservoir was almost beyond imagining. As the Great North American ice sheet melted, its meltwater pooled behind the ice in two joined glacial lakes, Agassiz and Ojibwe, spread across the middle of the continent. Together they held more fresh water than all of today's Great Lakes combined, dammed on their northern edge by a lingering dome of ice over Hudson Bay. This was the last remnant of a system that had already reshaped the climate once before, in the deep cold of the Younger Dryas. Now, it was poised to do it again. Around 8,400 years ago, that ice dam gave way. The evidence for the collapse is beautifully specific. Beneath the old lake beds lies a distinctive, red, iron-rich sediment. Geologists traced a plume of that same red mud flushed some 800 miles north, through the Hudson Strait and out into the Labrador Sea. Fossil clams from that seabed, sitting in the flood layer, date the event to roughly 8,200 years ago. The timing lines up. When the dam broke, more than 100,000 cubic kilometers of fresh water surged into the North Atlantic. That is a discharge on the order of 15 times the flow of the Amazon, draining for about a year. It was an ocean's worth of fresh water, released in months, and spread like a lid across the surface of the sea. Except this flood's real damage was not the drowning. It was the chill. The North Atlantic runs a great circulation that carries warmth north from the tropics. That circulation depends on salt, on dense salty water sinking in the far north and pulling warm water up behind it. Dump an ocean's worth of fresh water across the surface, and the salty water can no longer sink properly. The conveyor falters, and the heat stops arriving. Northern Europe, which sits far milder than its latitude has any right to be because of that current, felt the warmth pull back. What followed is a disturbing lesson, one written plainly in the record. Temperatures dropped by as much as several degrees around the North Atlantic, and by more in the ice of Greenland, and stayed down for roughly a century and a half. The dip is stamped into the Greenland ice itself, a sudden lurch in the chemistry of the ancient snow. It is the clearest such mark in the whole record of the last 10,000 years. A flood that lasted about a year reached forward and cooled a hemisphere for 150. Across the ancient Near East and Europe, the first farming villages were just taking root. In those same centuries, the record shows drought and upheaval. Some researchers read it as a push behind the spread of early agriculture. It is the same cold event, near 8,200 years ago, that shadowed the drowning worlds we are coming to. More recent work has complicated the picture in a telling way. Some studies now argue that the collapse of the ice dome over Hudson Bay mattered as much as the lakes. The meltwater released as that ice failed may have driven as much of the change. The exact bookkeeping is still being worked out. What is not in doubt is that a sudden freshening of the North Atlantic and a sharp, lasting cooling happened together. The lake is long gone. Its bed is the flat, dark, astonishingly fertile farmland of Manitoba and Ontario, ground that feeds people who have no idea they are living on the floor of a drained inland sea. But the mechanism did not vanish with the ice. The idea that a sudden flush of fresh water could weaken the Atlantic's circulation is no longer only ancient history. It is studied now with careful attention because the ocean that carried the heat then is the same ocean carrying it now. Number 4, the Missoula Floods. For most of the 20th century, geologists were certain of one thing above all, that the face of the earth is shaped slowly, grain by grain, over unhurried ages. One man looked at a landscape in eastern Washington and concluded they were wrong, and for that, he was ridiculed for 40 years. His name was J. Harlan Bretz. In the 1920s, he mapped a region called the Channeled Scabland, some 30,000 square kilometers of stripped and scoured basalt. It was a maze of dry canyons, dry waterfalls, and channels gouged straight through solid rock. The channels made no sense as river valleys. As Bretz himself put it, they ran uphill and downhill. They united and divided. They headed on the back slopes and cut through the summits, a network no ordinary drainage could ever produce. And scattered across the scabland were boulders the size of cars and small houses, stranded far from any rock they could have come from. Some carried well over 100 miles. Rivers do not do that. The only way such boulders travel is frozen inside rafts of floating ice, which means the water that carried them was deep, fast, and beyond anything in living memory. Bretz said the plain truth as he saw it. A catastrophic flood had done this. The reaction was scorn. In 1927, the leading geologists of the day invited him to Washington to present his case, and he walked into a room prepared to reject him. To colleagues trained to distrust sudden catastrophe, the whole idea sounded like a lapse back into superstition, into a world shaped by biblical deluges. He had first called it simply the Spokane Flood, after the nearest city, a single great inundation. The truth would turn out to be far stranger than one flood. And there was a real hole in his argument. Bretz could not say where the water had come from. Where does all that water come from? The answer came from another geologist, Joseph Pardee, who identified the missing lake. During the Ice Age, a lobe of the Great Cordilleran Ice Sheet had dammed a river valley in Montana with a wall of ice nearly a kilometer thick. Behind it backed up an enormous body of water, glacial Lake Missoula, holding around 2,000 cubic kilometers. It was a temporary sea larger than the state of Rhode Island, and ice dams do not last. When the ice failed, that whole lake drained toward the Pacific in days. On the way, it carved the Grand Coulee, a canyon up to 3 miles wide with walls 1,000 feet high. But here's where the story grows stranger than even Bretz first realized. The ice dam did not fail once. It failed, reformed, and failed again, dozens of times. The flood that carved the scabland was not a single event, but perhaps 40 or more. Each one released Earth's largest known freshwater discharge, on the order of 10 million cubic meters per second. That is more than 1,000 times the flow of the Columbia River, again and again across the centuries. At the height of these floods, a cataract, now called Dry Falls, thundered across a cliff 3.5 miles wide and 400 feet high. It was a waterfall 5 times the width of Niagara. At full flood, the water rose so high it drowned the cataract completely and poured over the top. The last of the floods swept through roughly 15,000 years ago as the Ice Age loosened its grip. Today, Dry Falls is bone dry, a silent wall of rock standing over pools of still groundwater. Bretz lived to be vindicated. By the 1950s, the tide was turning, and a group of geologists who had once dismissed him conceded, in a message sent to Bretz, that they had all become catastrophists. As open channel science and later NASA satellite imagery confirmed everything he had described, the discipline accepted that he had been right, and that the slow world can indeed break. The scabland has since become the closest thing on Earth to the giant flood channels carved across the surface of Mars, the landscape geologists study to understand catastrophes on another planet. In 1979, the Geological Society of America awarded Bretz its highest honor. He was 96 years old. He remarked to his son that all his old opponents were dead, and so there was no one left to gloat over. Number 3. The drowned country beneath the North Sea. On a wet September night in 1931, a trawler called the Kalinda was working the seabed some 25 miles off the coast of Norfolk. As the crew hauled the net up from about 120 feet, the skipper found a black lump of peat tangled in the catch. He broke it open with a shovel and struck something hard. Inside was a barbed harpoon carved from red deer antler. its teeth still sharp. It was thousands of years old, and it had been made by a human being standing on dry ground where there is now open sea. That single object proved something that sounds impossible. The floor of the North Sea was once land, and people lived on it. For more than a century, trawlers have pulled up the same kind of evidence. The bones of mammoths and woolly rhinoceros, the antlers of giant deer, worked flint, more carved points, even a fragment of a Neanderthal skull. All of it dredged from a plain that is now drowned. The archaeologist Bryony Coles gave that lost land a name: Doggerland. It was not a barren land bridge. Mapping led by the archaeologist Vincent Gaffney used seismic surveys originally shot by the oil industry to see through the seabed. It reconstructed a whole drowned country beneath the waves: winding river valleys, rolling hills, a great estuary, lakes, marshes, and woodland. It was, by the standards of its age, some of the richest terrain in Europe, and it was inhabited. Mesolithic hunter-gatherers lived on those plains, following the deer, fishing the rivers, raising families on land that no living person has ever seen. And the sea was already taking it. As the Ice Age oceans rose, Doggerland shrank across generations. It went from a broad continent joining Britain to Europe, to a peninsula, to a scatter of low islands. The water crept in decade by decade while people watched their world grow smaller. Then, about 8,150 years ago, the seafloor tore loose. Off the coast of Norway, an immense slab of the continental slope collapsed. It was one of the largest underwater landslides known anywhere, the Storegga Slide. Thousands of cubic kilometers of sediment broke away and slid into the deep, leaving a scar on the seabed the size of a small country. A landslide that size shoves the entire water column. It sent a tsunami racing across the North Atlantic. The wave left its sand on the coasts of Norway, of Greenland, of the Faroe Islands, and along hundreds of kilometers of Scotland. In the Shetland Islands, the wave ran up as high as 20 to 25 meters, and its deposits have been traced dozens of kilometers inland from the shore, and it swept directly across the low, flat, crowded remnants of Doggerland. By then, a few thousand people may have been living on the surviving high ground. They were the last of a nation, clinging to islands the sea had almost finished taking. The truly haunting part is what this world contained. This was not a dry basin or a drowning reef. It was a landscape with people in it, with camps and hunting trails and children. And one ordinary morning, the sea stood up and came ashore faster than anyone could run. Estimates of how many lived in the path of the wave run into the thousands. We cannot know how many were down on the shore that day, gathering shellfish or launching a boat. We know only that the water climbed to heights no one on that coast could have imagined it reaching. And yet, the wave alone did not end Doggerland. Recent work, including ancient DNA recovered from the seabed, suggests the floodwater drained back and the land briefly recovered. What finally erased the country was quieter and more total. It was the same relentless rise of the ocean, climbing through those very centuries. The sea from the earlier chapters of this list. It closed over the plains for good. The tsunami was a blow. The rising sea was the sentence. The people are gone almost without a trace. They survive only through what they let fall and what the water happened to keep. A harpoon of antler snagged in a net, a footprint pressed into drowned peat, a scatter of flint on a sunken hill, a whole nation of the living, reduced to a handful of objects and a name that strangers gave it thousands of years after the last of them drew breath. Number 2, the continent that became an ocean. Look at a map of Southeast Asia, and you see a scatter of islands in warm, shallow seas. Sumatra, Borneo, Java, the Malay Peninsula. Between them wash the Java Sea, the Gulf of Thailand, the South China Sea. At the height of the last ice age, almost none of that water was there. In its place stood a single, vast, low-lying continent, and its drowning is the largest loss of human homeland this list contains. Geologists call it Sundaland. When so much of the world's water was locked in ice, The sea stood roughly 120 meters lower than today. The shallow shelf beneath modern Southeast Asia lay exposed and dry. It was a landmass of about 1.8 million square kilometers, roughly twice the area of India. It did not look like the Southeast Asia of today. The climate was cooler and drier. Much of the land was an open mosaic of grassland and woodland rather than dense rainforest. A great river system threaded through it, gathering the waters of Borneo and Sumatra and carrying them out to the South China Sea. The evidence is unmistakable on the seabed. Beneath the Java Sea, marine surveys trace the buried channels of that vanished river, its floodplains and deltas, features that only form on open land. Along its eastern edge ran a line of deep ocean channels that never dried, even at the height of the Ice Age. The barrier was so old that the animals on either side evolved apart. We still mark it today as the Wallace Line. A continent was there. Then, the ice melted, and the ocean came for it. The drowning was measured in a landmark study by Till Hannabuth and colleagues, published in the journal Science in the year 2000. They dated the flooding of the Sunda Shelf and showed it came in surges. The fastest of those surges were driven by the great meltwater pulses. And a flat shelf is merciless. Where the land barely rises, every meter of sea level rise does not creep. It strides, pushing the coast inland by kilometers at a stroke. Modern analysis finds that rising seas erased more than half of Sundaland's area, and did it while human beings were living there. People had occupied that shelf for a very long time. Fossils from Sumatra place modern humans in the region somewhere between about 73,000 and 63,000 years ago. Families had been living on that land, generation after generation, for tens of thousands of years before the water took it. And when the fastest pulses came, the retreat was not gentle. On ground that lay almost flat, a shoreline could advance the length of a day's walk within a single generation. It took hunting grounds and campsites and river mouths that had been home for 100 lifetimes. There was no wall to build against it and no high ground close enough to matter. There was only moving inland, and then moving again. But the people did not drown with their land. They moved, and the movement is still legible in the living. In 2023, researchers read more than 700 complete human genomes drawn from dozens of Southeast Asian communities, and they found the fingerprints of that flooding written in the DNA itself. As the sea cut the land apart, it cut the people apart with it, isolating one group from another, island by island, as the plains between them disappeared beneath the water. The rise came in pulses, and the pulses matched the moments when populations split. The descendants are still here, the indigenous peoples of the Malay Peninsula, the forest groups of the Philippines, the islanders of the Andamans. Their ancestry on that shelf reaches back tens of thousands of years, and they carry lineages that trace to the drowned continent. It matters how we describe them. They are not relics or living fossils or leftover primitives. They are modern peoples with long, complex, ongoing histories who happen to hold in their genomes the memory of a homeland that the sea erased. Think about what that means where you are reading this. The seas of Southeast Asia are shallow, not by accident, but because they are drowned country, flooded plains, rather than deep ocean. The islands are the hilltops of a continent that the water left standing, and the descendants of the people who once crossed that vanished land on foot are still there, living on the fragments. Their ancestors could have watched a familiar shore turn to sea within a single life. Number 1. The flood that filled the Mediterranean. Roughly 5.5 million years ago, the Mediterranean Sea was gone, not lower. Gone. Where there is now a sea more than 2 miles deep, in places, there was a desert basin. Its floor lay baked far below the level of the world ocean, floored with salt. A barrier of rock sealed it off from the Atlantic, where the Strait of Gibraltar now lies. For a stretch of time, the Mediterranean was one of the strangest places on the planet. A dry chasm 5 kilometers deep, silent, blinding white with evaporate, a sea that had died. It stayed that way, on and off, across a stretch of time longer than our whole species has existed. Then, about 5.33 million years ago, the Atlantic found its way back in. What followed may be the largest flood the Earth has left any record of. We know parts of this with certainty, and parts by inference, and it matters to keep them apart. The salt is certain. In 1970, a deep-sea drilling expedition punched into the floor of the Mediterranean. It brought up thick beds of salt from far beneath the seabed, the buried residue of a sea that had evaporated away. Beneath the modern Mediterranean lie layers of this evaporate, as much as a kilometer thick. That the basin dried out is not in doubt. The event even has a name, the Messinian salinity crisis. The channel is certain too. In 2009, the geologist Daniel Garcia Castellanos and his colleagues published an analysis in Nature of Borehole and Seismic Data across the Strait of Gibraltar. They found a great erosion channel cut through the rock of the strait and running some 200 kilometers down into the Mediterranean basin. The incision was more than 200 meters deep. From it, around 1,000 cubic kilometers of rock had been stripped away. The scar in the bedrock is real, and it is enormous. What is inference is the speed. They fed the shape of that channel into a model of how rushing water cuts rock. Once the Atlantic began to spill over the sill, the process ran away with itself. It happened exactly as it did at Red Rock Pass, but on a scale beyond comparison. The deeper the channel cut, the more water poured through, and the more water poured through, the faster it cut. The buried channel suggests the water did not plunge over a single towering waterfall. Instead, it poured down a long, steepening ramp of rock, a descent of more than a kilometer sustained for month after month. In their model, 90% of the entire Mediterranean refilled in a window between a few months and about 2 years. At the peak, water dropped down a slope more than 1,000 meters high. The discharge reached something on the order of 100 million cubic meters per second, 1,000 times the flow of the Amazon, and the level of the sea inside the basin may have climbed by more than 10 meters a day. It is important to be honest about those numbers. The daily rise and the peak discharge are not measurements. No instrument recorded them. They are what the geometry of that real, measured channel implies when the physics is run forward. A later review held to a single main pulse, lasting months. It noted that the very fastest figures remain a preference of the models. The salt is observed. The channel is observed. The violence is calculated. What isn't in dispute is that a sea 5 kilometers deep was refilled from a dry floor in what, by any geological measure, was an instant. And here the scale becomes almost impossible to hold in the mind. So reduce it to one fact. Every drop of water in the Mediterranean today arrived after that basin lay dry. Think of the sea that would cradle the whole of the classical world. The water of Egypt and Phoenicia and Greece and Rome. The sea that Carthage and Alexandria and Venice were built beside. That extraordinary blue looks, in every photograph, as though it has been there since the beginning of the world. It is younger than the mountains that ring it. It is a refilled basin. It came roaring back through a single gap in a matter of months, 5 million years before the first city stood on its shore, and it has simply stayed full ever since. If you stand at Gibraltar today, the strait is about 8 miles wide. Ferries cross it. Tankers thread through it. The Atlantic and the Mediterranean lean against each other in a slow, ordinary current, and nothing on the surface hints at what happened there. But beneath that water, buried under 5 million years of sediment, the channel is still there. It is a canyon more than 200 meters deep, cut in a handful of months by the greatest flood the planet has left us the evidence to find. It is a wound no one can see, under a sea that exists only because the wound was cut. If you want to see more videos like this, click the video on screen now and make sure to subscribe.